Today, we're gonna look at a very advanced and general proxy pattern called the diamond proxy pattern. It's probably the most general and most complex proxy pattern out there and generalizable proxy pattern. So it's very important to know about. It's very important to use. It has a lot of benefits. I'm gonna walk you through all the details. I'm gonna go high level. I'm gonna really make sure you understand it. I'm gonna put together a very simple example for you, and then we're gonna dive into the more official templates that you can get started from. So watch this video, like and subscribe to my channel for more such educational content, anything from beginner to advanced. Today it'll be more advanced stuff, but I look forward to having you follow the channel. Hello everyone. Today I am super excited to talk about an advanced proxy pattern called the diamond proxy pattern. It is a probably one of the most general proxy patterns out there, in the sense that you can grow your contract to really any size you want. You can call like any function you want, add functions, remove functions from this diamond. So it's a core diamond contract that can delegate function calls from external users to any facet it has, and multiple functions can sit on each facet. The facets can call each other. The data can be shared between certain facets but not others, and so on. It's a very complicated, very general and useful and advanced proxy pattern. So it's a very exciting one, and today we're gonna dive into it. So welcome. A really good idea is to go look at the actual ERP. So it's 2535 from Nick Mudge. It's a great read here. It's very comprehensive. He did a fantastic job, of course, putting this together. They also have a Discord server as well around this diamond structure and proxy contract. But I just want to kind of give a very high level here of what it is, and then we're going to dive into a simple example that I put together, and then we're going to look at Nick's great example as well. It's more comprehensive, but I wanted to just start the super simple example for you guys. Anyway, we'll dive into his example as well, and then yeah, that's it. We'll call it a day. In this example, he's actually showing two diamonds. So imagine you have two diamonds. A diamond, again, is like kind of this proxy contract that a user can call, and then the diamond itself delegates to its facets, this call. So you see the diamond has some code in it, which certainly can have its own code. Typically that would be considered more like kind of immutable code maybe. And then it has some data in it as well. And then it does have a facet A, which has some code A. And diamond one can, this code D can call code A and whatnot, and it can actually change data A and whatnot. So he's just trying to show a lot of these permutations that are possible. There's also another facet that diamond one has, facet B, and it can also call that code B. In fact, this code D calls both, but, and this is kind of the delegate call, right? And then diamond two has its own data as well, and also has a delegate call that calls out to these other facets and whatnot. So you can actually have multiple diamonds that even share facets and whatnot, which is kind of general. This great EIP description here goes into all the pros and cons and everything. So as he says, I think number one here is a good kind of summary: a single address for unlimited contract functionality. You can also exceed the 24 kilobyte maximum contract size, because you can just keep adding facets and whatnot, and it'll just keep growing. So this is probably one of the most general patterns. All right, so let's kind of dive into the analogy. Why is it called a diamond real quick? I think you've caught onto that, but I just wanted to give you a super simple example. If we just consider the diamond contract in itself, the core, let's consider that an uncut stone. So this is something that hasn't been cut yet. If you're familiar with diamonds, they start as these very rugged stones that don't look like they'll become much, but then they have these facets caught in them and they become absolutely beautiful. So, all right, we start with this uncut stone, fine. Now, there's not a lot of functionality here in itself, of course, so we need to add some facets, aka some actual like usability, some functions into this. So this is where the cutting happens. I couldn't show like an uncut stone with just one cut facet. I couldn't find a picture like that, so we're just going to jump to the diamond. But just imagine only one facet has been cut into this uncut stone. And then that's adding another contract that's adding functions and capabilities to the diamond. The diamond will delegate call out to facet one. But, visually we can show it as a diamond with one facet here. Fine. We add another function, or we add another facet with potentially multiple functions, facet two, and this sits here now. And of course, diamond can also call that. That's not shown so clearly there, but of course, the whole point is that diamond can then delegate call to facet two as well. And then, but this, you can visualize that as sitting here. So you can add an arbitrary number of facets, okay? And this is kind of what he's then showing here, except I'm not showing multiple diamonds, but I don't know. I just like this visual. You start with nothing and you kind of just add these facets one at a time. You're kind of cutting this diamond. That's the whole point of it, right? Two main things I would say is kind of at the key, like kind of the meat of understanding the diamond contracts. Okay, one is how do we cut new facets into the diamond? And two is once we've cut a facet, how do we actually call it? Like how do we actually interact with it and kind of get access to its functions? So that's what I wanted to just quickly dive into here. So the first is anatomy of a diamond cut. So someone has created this diamond, that is the owner of the diamond contract. We're showing this person to the left. This person then says, I want to add function A from a contract at address B. So we imagine that some contract has been deployed at address B, and that contract has a function called function A. You can have multiple functions, but for now we just want to add function A. We can always add another function from it later on too. Like maybe not now, but later on we'll add function B and so on. That's kind of important in the implementation. But anyway, so we want to do that. So we call the diamond contract. We just have a single address A that we call always, right, to interact with. So how do we actually add it? The way that the code does it is first it gets the address from the caller. It says, okay, fine, you want to add this function. At what contract does this sit? What's the address of the contract? And then after that, it says which function selectors from that contract do you want to add? Because you can add, again, a subset. Internally, the storage here is updated. This variable called selector to facet and position. Position just relates to, you can have multiple facets. So which position in the array of all the facets does this facet exist and so on, right? And the same with the selector and whatnot. So you'll see this position kind of come up. But anyway, the point is that we can now map the function selector of the caller. The caller says, I want to call function A. We get the function selector from that, right? The first 4 bytes of that kind of call data, if you will. And then once we have the selector, we look in the map and we say, hey, do we actually have a facet where this function sits on? And then this mapping will say, yeah, we have facet 1. Function A sits right there. Or no, there's no such facet. Fine. Notice also you can't clash these function names, right? Like, and not just the names, but also like the selector. You know how sometimes the selectors can clash even though the functions are called different things depending on what kind of parameters. So you can have clashing. But anyway, you can't have that happen. And there is a check for that in the code to prevent that. So that's a diamond cut. Now we have the cut. Now we need to actually make it useful. Like someone actually needs to call it. So what is the anatomy of a call? Now consider this person to be anyone. Technically anyone who could call a contract, but anyone really, just for this example. And they say, I want to call function A with some parameters. The parameter is not important, but just to show that, of course, you can forward that as well. All right, the diamond contract then says, great, you want to call function A. That's cool. Let me get the facet that it sits on. So first of all, let me get the selector of what you want to call. And then ask, do I actually have a facet? So if I do have a facet, great. I found it, and now I'm actually going to delegate call to that facet. So again, the facet is a contract that exists at some address, here address B. So I'm going to actually delegate call to that contract, and I will send the parameters along and whatnot, and I'll get the result back, and I'm going to send the result back to the caller. So as far as the caller is concerned, they just called the contract, function A on a contract, and they got the result back. Right? So notice how this can really be generalized. We can have facet 2, facet 3, facet 1000 with function Z. Okay, and the caller calls function Z. Right? They don't need to specify the facet, of course, right? It's all abstracted away. They just call the function, they get the results, everyone's happy. But you as a developer, you're more happy because everything is generalizable like this and you're not running into any contract size limit and whatnot, and everything is still contained within a nice framework. Good, so that's how to do a function call. What we're gonna do now is dive into a very, very simple example that I put together. Again, go ahead and clone this. It's public, please clone it, use it. I hope it's useful. Go under contracts, and we're going to take a look at the base diamond. I left Nick's kind of statement here from his own template. We'll get into that in a second. Just I want to make sure that I show him respect, of course, but I just want to say that he's not responsible, of course, for any bugs here that I potentially made. But anyway, this is a base diamond contract here, and this is how to do a diamond cut. Now, notice that we're actually we're relying rather on the library libdiamond, which we're importing from our library folder, which we'll get into in a second, to actually do the cut. So the meat of the code is not shown right here, but this is the function that the owner calls from outside. And then we have the actual function down here to call a facet, which we'll get into a second. I want to dive into the cut first though. So if we can just go into the libraries We can go into libdiamond. The first thing I just want to kind of talk about is how it handles storage. So libdiamond, that is the library that actually handles all the storage. The diamond contract itself, diamond.sol, does not have any storage in it. It's the library that handles that. And it starts the storage in this position here, which is the hash of this string, diamond.standard.diamond.storage. You can put any other string you want, but this is just kind of a standard. So if we scroll to the bottom, we'll actually see what is the storage space really. Well, at that location in storage, whatever number this hash comes out to be, we can always retrieve that by using this function called diamond storage, and it'll return the slot at which this diamond storage here starts. Okay, so this is a struct, and this just represents what we're storing. So the struct here has a selector to facet and position. So we can go from a function selector that someone calls, either a user calling it or the owner wanting to add a facet. We still need to be able to map these functions that sit in the facet to the selector to the facet, right? So selector to facet, and then this position again, which is the position in the array. And then we can also map, we can get all the facet function selectors as well. So given its address, we can get all the selectors and whatnot. And then of course, we're going to store all the facet addresses that we have. So we can have up to 1,000. That's again where this position comes in, because we need to know where. And then of course the contract owner. So all these things, we can keep adding things to this diamond storage if we want, what we want the diamond to store in general. But right now we just have the owner, we have the addresses and whatnot, and the selector mappings. Okay, so that's very simplified version of it. I just want to talk for a brief second about a facet cut. So this is it's a struct that represents the data necessary to perform a facet cut. So one of them is what is the address of the contract that you're cutting onto the diamond, so to speak, that will become the facet. You need to basically tell the contract that. And then you also need to specify the function selectors from this facet, which again can be one or more from that facet. Okay. And then we have a struct called facet address and position. So again, this keeps track of the facet address, and it also keeps track of the, basically function selector array. So basically, how many function selectors have we kind of obtained from that facet address and whatnot. And then there's the facet function selectors, which just says basically, given a facet, it has some function selectors, and it also has an address position, right? It has a position in the facet address array. We have a global array where we track all the facets that you just saw. Okay, so how do we actually make a diamond cut? So again, this diamond.sol calls this library, and it calls specifically this diamond cut. You need to put the call data in this facet cut format, which again is this here. I'll show you in a second how you do that. And then when you enter the function here, we're basically going to get the facet address from the call data. So which contract are you talking about? Which contract do you want to cut into the diamond? And notice that it can already exist, right? So we have to check that. We do that in a second. And also, which function selectors do you want to find? So we just retrieve what the users or what the owner want to cut into the diamond. Now we retrieve the existing storage, right? So we're going to retrieve the diamond storage. And then what we're going to do is we're going to just find out, have we already cut this facet before, basically, right? So basically, if the facet does not exist, we need to add it. That's what we do here. So we just make sure to add it. But if it does exist, we're obviously not going to add it again. So that's just kind of what this code is about. And we use this selector position to indicate whether there has been any function ever added to that function facet as a kind of an existence proof of the facet. Okay, now we know it exists. We're going to loop over all the function selectors that we want to add to that facet, or we want to kind of add from that facet maybe, or from the contract to the facet, if you will, sorry. Okay, so we're going to make this loop. And basically for each selector we want to add, we're going to get the actual selector. It's a byte 4 again, it's the first 4 bytes. And then we're basically going to ensure that the facet does not already exist. So we're going to get the current facet address, right? So we're going to say, hey, is there already a facet there? And then we're going to actually just add it. So we're going to say, update the function, select the position. We're gonna set the facet address, right? So again, this is all under the selector. And then, we're also gonna update the basically facet address. We're gonna map the facet address to the selector. So we're gonna push the selector onto this array and then update the selector position. And there you go. We have now updated the mappings that'll map the selector to which facet it sits on, right? Essentially here. And then which facet address holds which selector, okay? Which is here. So we've kind of done this mapping here. That's it. We've cut a facet into the diamond, and we have updated our internal storage so that if anyone calls it, it knows which facet a function sits on, and we'll do that in a second. That's it. That's all there is to the library, really, because the main diamond.sol actually handles the delegate call. So that's as simple as I pretty much could make it, just as an example here. So cool. That is the cutting part. That is what we discussed here. Let's jump down to the actual function call. So now we have the facet. How do we call it? Great. Jumping back into diamond.sol, we'll see here that we have a very comprehensive delegate call. It is more complex than a usual kind of proxy delegate call for obvious reasons. We have to actually find, okay, someone sent us some call data. We have to see which function select they want to do, and we have to find the facets. That's what we do here. So we're going to retrieve the storage from our library, and we're going to find, so this message.sig, that's kind of the function signature, if you will. So that is the selector we're talking about. So we're going to retrieve that from the caller, which again can be anyone. We're going to then find the facet address. Okay, if that facet address actually exists, well, then we can continue to delegate call to it. So we found the facet now that has that function the user want to call. Now we're going to go into assembly here, and we're going to basically make the delegate call. So there are a few reasons for using assembly. So one is that a normal, at least before Solidity 0.8, you actually couldn't return anything from a delegate call. So you had to kind of use assembly. But another thing is also there's some gas savings even beyond version 0.8 because you can kind of use the beginning of the memory array and kind of override it in a sense. So anyway, what we're going to do is just copy the call data. So someone just sent us some call data. It can be a string of any bytes, right? It can be any bytes. They just called our diamond.sol contract with that. We just confirmed that there is indeed a facet that has the first 4 bytes of whatever arbitrary bytes they sent. At least the first four bytes is something that we recognize. We know there's a facet that can take that function call. Okay, fine. But we're going to take the rest now. We're going to call data copy. We're going to copy the data, all of it, call data size. We're going to grab all of the call data. And what we're going to do is going to delegate call. We're just going to forward whatever gas is remaining here. We're going to call the facet. This is where the actual facet gets called. You see this? This will change depending on what function you call. Maybe you call another function. It could sit on the same facet, or you call a function that sits on another facet. That is determined right here. And we're going to delegate call out to that. And then we're going to basically just call it with zero, like we're just going to say in memory, you're going to find the call data to use from 0 to the call data size, and then the return data will sit in basically location 0, right? So then the result comes back. We're going to return data copy as well. This result is not, the data is more like a flag that says whether it failed or not. And then we're going to actually copy the return data, any return data potentially. That doesn't have to be any, but there could be some. We're going to copy that. Okay, cool. If it did not revert, then just return the return data. And if it did, then revert. That's it. That's pretty simple, I guess, in a sense. We're just going to look at a mapping, find what facet the function sits on, just delegate call to that contract, right? And then the contract will handle the rest. It could fail, it could not fail. We don't care. That'll be handled here. That's it. That's a diamond contract. Okay. So pretty powerful concept, I'd say. Now we have a folder called facets. And for this, I just added some very simple facets. So one is an ERC20. So it has its own storage library, kind of similar to that diamond contract. So the facet itself doesn't hold any storage, but it holds it in that lib ERC20, basically another library or another contract. So then we're going to basically create this contract called ERC20 Facet, and that'll become a facet of the diamond. And we're going to have various functions here. You can see ERC20 mint, so you can mint, you can approve, you can just get balance of, you can transfer from, and so on. So that's pretty nice. We have another facet called the NFT Facet, which is another facet we'll add, and it has another set of functions here. And you can even see that it interacts with the ERC20. And then there is a mint with ERC20. So this is an NFT that's talking to the ERC20 library. Okay, so you can kind of see how they can interact as well. All right, so that's the facets. In general, again, as mentioned, for the ERP2535, I want to make it clear that, again, this code here is just a very, very simple code. This is just for educational purposes, not production. You will need a loop facet. A loop facet is a facet that can help introspect the diamond, tell you which functions are available, which facets are available, and so on. Okay, so you always need that to adhere to the standard. Okay, fine. All right, so that is it in a nutshell. And if you actually run the test, I wanted to show you the call data, how it looks. But if you go under the test folder here, and you can run the test with npx hardhat test, if you actually go under here, you can see how the facets are added. And you can see this test right here should add the NFT facet. So you can actually, first of all, you get the NFT facet, right? That like you need to first deploy the contract, right? So you do that, you deploy it. Then you get the selectors of this. This get selectors is a helper function, and you can see it right here. So it's just a way in Hardhat to get the selectors of a contract's interface. So it'll just pull that out from the interface that's known and just return the selectors. So, it's just a helper. Okay, so now you have the selectors. Then now here it comes, right? Now you need to actually put this data into a Facet Cut format. So you call Diamond, you call the Diamond Cut function. This will, kind of call that library version of the Diamond Cut. And this is the Facet Cut format right here. So you need to say, what is the facet address, right? And then you just say it, well, we just deployed it. It's NFT Facet.address. And then what are the selectors? Well, we just pulled those out from the NFT Facet. So we as the caller need to put this together and call it. So there you go, we called it and it added the facet. So now we can actually test that it indeed added the facet. So notice that we say, oh, by the way, there's an NFT facet sitting at this address. Notice that we're using the diamond's address, right? Just like a normal proxy. We're actually saying the proxy, like the diamond.sol is deployed somewhere. And that address A, we're saying has all the functions of the NFT facet, right? So we'll tell our users, go call diamond.address. They think they're calling, they are through the delegate call, but they think they're calling directly the NFT facet, right? They're not. They're calling the diamond's address, and then it'll delegate call to the NFT's address, so to speak, right? That's just like how proxies work, right? Anyway, we just confirmed that everything works as expected. I'm just doing a bunch of minting and balance of and whatnot examples here so that everything works as expected. Then we're going to cut the ERC20 facet. So we're going to do the same. We're going to construct this facet cut data, and we're going to call the diamond cut, and we're just going to confirm everything works. We're also going to confirm that the kind of play between the NFT and the ERC20 facets, like they each have their own storage, that those storages can call each other, those data blobs, if you will. So that's what happens here. So that's just a test. Take a look at it. You can run the test self, expand it. Hopefully it shows you how to call diamond contracts in general, what format to use. So that's everything. Very, very super simple contract. But I want to show you, Nick's contract here as well. So if you go to Nick's repo here, he has a bunch of different diamond contracts. This is Diamond 1 Hardhat. He has one called Diamond 2, Diamond 3. And basically, this is a great way to, in fact, I want to show you here the more general repo here maybe, right? So this is the diamond, and he's like linking to the diamond repos here. Okay, so go to this one, mudgen/diamond on GitHub, and then you can go to diamond 1. All right, so let's see here. This is very similar to what I put together. In fact, I took this and kind of boiled it down to an even simpler example, but this is better to start with because it has that loop function I talked about and whatnot. So in here, this should look familiar to you. You have your contract, you have your diamond.sol contract. As you can see here, you can do, this will do the delegate call for you. This will do the diamond cut. Sorry, that was the constructor. The diamond cut in this case, okay, this is important. The diamond cutter is actually added as a facet. Okay, it becomes a little meta now, but the diamond cutter function is already a facet to the diamond, okay? So that's why you're not seeing, that's one thing I also did. I kind of added explicitly in the diamond contract so that it didn't become a little bit strange like that. But so one facet is the diamond cutter. So the owner calls that facet, and then that will ensure to cut other facets, okay, into the diamond. All right, so that's the diamond.sol. Let's go into facets. So in his example, he has a diamond cut facet, like I just said. It sits in its own facet, and all it does is cut the diamond. This is similar to what I showed, but I just put it in the main diamond.sol contract, but that's the same, so no problem. Then he has this loop facet, which is an introspection facet. It is required again by the 35. So here you can get all the facets, right? Get all the facets and their selectors. So this is just a way to introspect the diamond again, kind of, because it can get unwieldy. You can have 1,000 facets each with n functions, right? And like it just becomes, okay, does it have this function? Yes or no? I don't know. So that's what the introspection is about. So all this handles that. So you can get all the facet addresses. Again, you can get the selectors, and you can get everything together. So it's a very nice addition to it for sure. There's also the ownership facet, which he has put as a separate facet as well, which is great. That's also a facet. So you can actually transfer ownership. You can get the owner, but all handled by its own facet. All right. And then he has 2 test functions. In my case, that was that NFT and the ERC20, but in your case, it can be whatever you want here. You can have test 1 or test function 1, test function 2, yada, yada. Okay. And then again, another facet with another set of test functions. So this is where you would add your own facets. The libraries, again, that's the main libraries, the library Diamond. We just looked at that, but it also has its own storage, right? And it just handles the cutting in a very similar way to that we just showed. But notice that it has a lot of other functionality that's very useful. Like, for example, you can add functions. So you can just call add functions. You give the facet address and you give some function selectors. So for example, you want to add some additional functions to an existing facet. You can also replace some functions you've already put in your Diamond contract from a facet. So it has a lot of expanded capabilities here. You can also remove functions and whatnot. And then you can even initialize. You can call an initializer against the new facet that you created, right? Like in a traditional proxy way, you can't really use the constructor, right? In these like kind of upgradable patterns. But so it is much more complicated than the initial example I've shown, but that was on purpose. That's why I did that initial example. Okay. Then you have some upgrade initializers. So of course, all this is upgradable. You want to be sure that you can upgrade your facets and so on. So to do that, you need to actually call the init function on the new facets and whatnot, right? So anyway, this is just the kind of a very good repo to start off with. Check out all of them, like 1, 2, 3, just to see which one is closest to your use case. But I hope you have gained a better understanding of this advanced Diamond structure, that it's probably one of the most general proxy patterns. Really, you can add any amount of contract, any number of functions across different contracts that can share data in all kinds of random ways. So it's rather complex, but it's also really powerful. And I hope you gain a better understanding. So it's really just kind of expanding on the delegate call idea of the very basic proxy that just delegates call to an implementation contract. And through the mappings, it figures out which facet a function sits on and whatnot. I hope this was helpful. It was a lot of fun walking you through this. Again, visit my repo. Please feel free to clone it, star it, and follow it and whatnot for updates. Follow my general channel, subscribe and like. Feel free to comment if you like this content. Thanks for watching.